This is your 1 point or 11.3 geometric sequence in series. Yes, we skipped 11.2. A geometric sequence is generated when we start with a number a and repeatedly multiply by a fixed non-zero constant r. A is in fact considered the first term, and r is the common ratio of the sequence. The nth term of a geometric sequence is given by this formula. Very important. Let's look at the first problem where it says find r and s of n for 2, -10, 50, and so on. Well, 2 is the first term, so I know already that a is equal to 2. Now let's go ahead and find r. To find r is the common ratio, so r will be equal to -10 over 2, or it should also be equal to 50 over -10, which is also equal to -250 over 50. It is called common ratio because the ratio from the second over the first term should be identical to the ratio of the third over the second, and so on. So my common ratio here, if I simplify, I get -5. So I will say r is equal to -5. Now, using the formula that you see up here, I would therefore say s of n is equal to a, which is 2, times r, which is -5, to the power of n minus 1. And this is my final answer. Let's look at 2. The third term of the geometry sequence is 128, and the sixth term is 54. Find the fifth term. Well, the third term, it seems like I got s of 3 is equal to 128, and I have s of 6 is equal to 54. Well, from a3 to a6, how many times do I need to multiply by the common ratio? If I take you back to problem number 1, 2 times -10, well, if I'm going from 2 to -10, I multiply by -5. From -10 to 50 by another -5. From 50 to 50 by another -5, and so on. So if I want to travel straight from 2 to -250, I'll multiply by -5 to the power of 3. In other words, from a, I can call it a1 or a, to a4, the difference between the subscript, which is 4 and 1, gives you the power. Now, looking at a3 and a6, to go from a3 to a6, it seems like I will multiply by r to the power of, I'll put times r to the power of 6 minus 3, which is 3. In other words, I will therefore say 128 is equal to, or 128 times r cubed, because that's what we multiply by, to get 54. From here, I will divide both sides by 128, and once I divide by 128, I end up with r cubed is equal to 27 over 64. So r itself is equal to 3/4. Once I get r, now I'm looking for the third term of the sequence is find the fifth term. Since I'm looking for the fifth term, now 2 ways of doing it. I can do it from a3 to a5, knowing that if I'm moving from a3 to a5, it seems like I will do a3, which is 128 times r to the power of 2 to get to a5. That's one way. Or I can go from a5 to a6 to say a5 times r is equal to a6. That's another way of doing this, knowing that a6 is actually the value that we have, which is 54. So I can just put 54 here, and I can replace now r by its value, r being 3/4. So I will write here 3/4, and I will write here also 3/4. Now from here I can just apply my simple algebra. So I will have a5, this is an a, is equal to 54 times 4 over 3. And once you apply it, you get 72 as your final answer. You have gotten the same thing if you were using this way. All right. Sn stands for the sum. So the sum of a geometric sequence is called geometric series, and we will use Sn as the sum of the geometric sequence. Now, once again, we have a formula here. The first thing you need to understand here is that A is actually the first term, and N is the number of terms, and of course R is the common ratio. Let's look at problem number 3. It says find the following sum. First 8 terms of 2, -6, 18, -54. Well, we got enough. We want the sum, the S8 actually. What we're looking for is S8. We have the first and second. So with the first and second, we can actually identify the rate. We can identify first A. A is equal to 2. We know N, which is equal to 8 because they're asking for the first 8 term. And R is equal to -6 over 2, which is -3. With this information, I will now say S8 is equal to A, which is 2, times 1 minus R, which is -3, to the power of N. Let me go ahead and fix my parenthesis. That'll be -3 to the power of 8, and I close my parenthesis, over 1 minus R, which is -3 again. We can simplify this, and if you simplify it, you will get -3,280. And that's the sum of the first 8 terms. Alright, let's go ahead and look at the next one. The next one says, this one has now a summation sign and goes from 3 to 7, and it's raised to the power of n, in case you cannot see. So what I would do is, I would still look for n. From 3 to 7, how many terms am I looking for? Well, that would be 3, 4, 5, 6, and 7. That would be a total of 5 terms. You can count it with your fingers if you need, because I just did. 8,3 is equal to, you plug in 3 here. Why am I looking for 8,3? Because that's the first term of this sum. 8,3 would be 1/2 to the power of 3, which is equal to, times 5 of course, which will be 5/8. This is a 5 here. Now I also need the rate. R here is given, it's 1/2, it's whatever is being raised to the power of n. From here I can easily know that S, which is the sum that I'm looking for, is equal to 5/8, that represents my A3, or the first term, times, I can make a long line, 1 minus R, R being 1/2 to the power of n, and here is 5, over 1 minus R, which is 1/2. I'll keep this one in parentheses just to highlight the value of your R. So if you calculate this, you will end up with 155 over 128. Let's move on to the next problem. The next problem now says, consider a big yummy birthday cake. It is so tempting that you sit down and eat half of it all at once. A couple of hours later, you eat half of what is left. A little later, you eat half of what is left again, and you continue this process. How long will this continue? To be honest, you will never finish the cake if you keep eating just half of what's left, because you will never eat the whole leftover. So it will keep going forever. But you're probably wondering, how come it's going to keep going forever? This is just theoretically. Because common sense, we would think that the cake will eventually finish. Write a series that represents the amount of cake that you have eaten. Well, the first thing you do is half. After that, you eat half of the half, meaning 1/4. After that, you eat half of the half of the half, which is half of the previous term, and that'll be 1/8. And half of the previous term, that would be 116, 132. And if you keep going, you will go on forever. No matter how many terms you add to the sequence, the sum will never exceed what? It will never exceed 1 because you never finish it. 1 will be the total. Now, let's go ahead and look at this. As n approaches infinity, s of n approaches, in other words, as you keep eating half and half and half, how much is the leftover getting close to? Of course, it gets close to nothing. But as n approaches infinity, the sum of what you've eaten get closer to the whole, meaning to 1. If the absolute value of r, which is the absolute value of the common ratio, is less than 1, then the sum of an infinite geometry series is s equal a over 1 minus r. Now let's find the sum of 0.3, 0.03. Now, first thing I need to do is locate my, by the way, this is very important, so know this. Let's find this sum. As a, or a here is the first one, which is 0.3. The rate here will be equal to 0.03 over 0.3. And if you calculate this, you get 0.1. So s is equal to a, which is the first term, 0.3, over 1 minus 0.1. I'll put 0.1 here to make you understand that it's not just 1. Well, this is 0.3 over 0.9. And if you simplify this, you get 1/3. Alright, let's look at the next one. The next one says a tennis ball is dropped from a height of 24 feet and it bounces 40% of the height from which it falls on each bounce. What is the total vertical distance the ball travels? First of all, our starting point, or the first value, is 24. And the rate, 40%, meaning 40 over 100. And if you divide 40 by 100, you get 0.4. That will give you by how much you're adding, or the rate, by how much you multiply. So s here is equal to the first term, which is 24, over 1 minus r. R here is 0.4. That's 0.4. This is equal to 80 minus 24. It will be 24 over 0.6. Or 1 minus 0.4 is 0.6. So instead of 0.6, I can put 6 over 10. And then I will do a copy change flip to get 24 times 10 divided by 6. And if you simplify, I'll go ahead and simplify this. I'll do it by 2 and by 2 to turn this into a 5 and this into a 3. And I can do 24 by 3 and by 3 to get the final answer of 56, I believe. That's 8. 5 times 8, not quite 56. I know the final answer. This is 40. Now, sorry about that. So my answer is 40 for now. 40 is the distance, the sum. But you got to keep in mind, the tennis ball is traveling up and down. So as it goes up, it will travel 40. Down, it will travel another 40. So it will travel 40 total from each way. That will give you a total of 40 plus 40, which is 80. Now, remember, we're looking for the total vertical distance the ball travels. That's important. The fact that it started at 24 feet up doesn't tell us that it traveled 24 feet originally. So let's go ahead and take away the 24 feet of the original distance to get the final answer of 56 feet.